I'd like to continue with 4.8, and today I'd like to show you how to solve these algebraically. So when we have an exponential or a radical, we still want to get our x alone. So we have 3x to the 4/3 equals 343. So to get my x alone, I must first divide by 3. That gives me x to the 4/3 equals 81. How do you inverse a 4/3 power? You would take it to the 3/4 power. So that is x equals the 4th root of 81 cubed. We put that 4th root on, so the 4th root of 81 is a plus or minus 3, and I still have to cube that. 3 cubed is 27. Negative 3 cubed is negative 27. So I get plus or minus 27. On my next problem, it is the square root of 4x plus 28 minus 3 times the square root of 2x equals 0. Our x is under two radicals, so it would be best if each of them were on one side of the equal. So since this is 0, I can simply add this 3 square root of 2x to both sides. And over here, I get the square root of 4x plus 28. And on this side, I get 3 square roots of 2x. Now that I have both sides with a square root of x, I can square them to undo the square root. So this gives me 4x plus 28. And this one gives me 3 squared, which is 9, times square root of 2x squared is 2x. So that is 4x plus 28 should equal 18x. Subtract 4x. 28 equals 14x. Divide by 14. And x equals 2. Now since this one started out as a problem with an even root, I should double check that my answer does not give me a negative. So when I put 2 in there, I get 4 times 2 is 8, plus 28 is 36, square rooted would be 6. I put my 2 in here, 2 times 2 is 4, square rooted is 2, times a negative 3 is negative 6. And 6 minus 6 is 0. So it does check out, it's okay. Let's try the next one. A negative 2 times the cube root of x plus 6 equals 12. Subtract 6. Negative 2 times the cube root of x equals 6. Want this cube root alone? Divide by the negative 2. Cube root of x equals a negative 3. How do you inverse a cube root? You would raise it to the 3rd power. So this is x equals a negative 3 cubed is a negative 27. On the next problem, x plus 2 equals the square root of 2x plus 28. Again, I have my x on each side of the equal. Here it's under a square root, so that's where I will undo. The inverse is to square, so I must square this entire quantity of x plus 2. X plus 2 squared is x squared plus 4x plus 4. If you did not get that as a square, then I would suggest here you have to multiply out x plus 2 times x plus 2. And then you will get this trinomial, x squared plus 4x plus 4. When I square this side of 2x plus 28, square rooted, I get 2x plus 28. Since it's a square, everything must be on one side to equal so I can factor. So I'm going to subtract the 2x and the 28. X squared plus 2x minus 24 equals 0. Now I can factor. The factors of 24 that differ by 2 are 6 and 4. I need a positive 2, so the 6 will be positive, the 4 negative. So here I get a 0 at negative 6, and here I get one at 4. Again, it started out as a square root, so I must test my answers. Negative 6 plus 2 is negative 4. Negative 6 times 2 is negative 12. Plus 28 is 16. Square rooted is 4. Does negative 4 equal 4? No, it does not. So that one is extraneous. 4 plus 2 is 6. 4 times 2 is 8 plus 28 is 36. Square rooted is 6. 6 equals 6. Yes, that one works. So my solution is x equals 4. Now I have one more method to teach you, and that is the substitution method. And why would you use the substitution method? Because when we have negative exponents or rational exponents, we can't often solve for our variable x in these power functions. So what we're going to do is substitute in a u in the place of the linear term. And how do you know what's considered a linear term? It would be the term right before your constant. So 20 is my constant, so this will act as my linear term. So that is why I said let u equal x to the negative 1. So wherever there's an x to the negative 1, I'm going to replace it with a u. So this will give me 3u squared minus 19u plus 20 equals 0. And now it becomes a square that I can easily factor. 3u and u, factors of 20, 4 and 5. Inside I have 4u, outside I have 15u. Do 4 and 15 add up to 19? They do, and to be a negative 19, both would have to be negative. So when I solve this one for 0, I would have u equals, add the 4, divide by the 3, 4/3. And here I would have u equals 5. But was I looking for u, or was I looking for x? So I have to go back here, and then resubstitute in x to the negative 1. So it is x to the negative 1 equals 4/3. And x to the negative 1 equals 5. The inverse of a negative 1 is a negative 1, which means x is 3/4. And same with here. X would be 1/5. Let's try another one. 10x to the 2/3 plus 29x to the 1/3 plus 10 equals 0. My linear term, or the term before the constant, is x to the 1/3. So I'm going to say u equals x to the 1/3. So this becomes 10x. Excuse me, not x. We're replacing it with u. 10u squared plus 29u plus 10. Now I would factor 10u squared. I would try 5u and 2u. Likewise with the 10. 4u squared in the inside, 25u on the outside. 4u and 25u adds up to 29u. That's good. So my zeros, u equals subtract 2, divide by 5. Subtract 5, divide by 2. But again, I'm not looking for u, I'm looking for x. So I come back and substitute the x in there. X to the 1/3 equals negative 2/5, and x to the 1/3 equals negative 5/2. How do you undo a 1/3 power? Raise it to the reciprocal, which would be 3. So this gives me x equals a negative 2 cubed is a negative 8 over 5 cubed is 125. A negative 5 cubed is negative 125 over a 2 cubed is 8. And let's try this tetranomial, which is in the linear position, constant linear, x to the 1/4. So I'm going to replace u in for my x to the 1/4. So this becomes u cubed minus 2u squared minus 4u plus 8. Now when you have a tetranomial, you're going to go 2 by 2. Ignore this part for a moment. What is common to the u cubed and the 2u squared? A u squared. Divide out a u squared, you get a u minus 2. Now ignore that part. And what is common here to the negative 4u plus 8? A negative 4, divide a negative 4 out, you get u minus 2. Now that gives me two terms. What is common to these two? They both have a u minus 2. If I divide a u minus 2 out of here, I get a u squared. Out of here I get minus 4. This one factors further. U minus 2, u plus 2. On both these, I get u equals 2. On this one, I get u equals negative 2. Am I looking for u? No, I'm looking for x. So I come back here. So it's x to the 1/4 equals 2. That's again, so I don't have to write it. And x to the 1/4 equals negative 2. How do you undo a 1/4 power? The inverse would be to raise to the 4th. 2 to the 4th is 16. Negative 2 to the 4th is 16. So no matter what, x is 16. It just so happens it will be a triple root, because I get the same answer 3 times. And the last thing I'd like to share with you today is a regression. So here we have an ordered pair T comma R, where R is the circular area in square feet of oil that leaked from an oil tanker in T minutes. So in list 1, we're going to put our times. 1 minute, 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes, 35 minutes, and 60 minutes. In list 2, we're going to put our area, 28.26, 706.5, 2826, 6358.5, 11,304, 17,663, 34,618.5, and 101,736. Now, here's a clue. It's area. Area involves units squared. So if I look at the scatter plot of this, it could be either exponential or power. But since area is units squared, I am thinking I'm going to get an x squared out of it. So when x is your base, that's a power function. So let's try our power regression. and we get y equals 28.26 x squared. And I know that's a really good fit because my coefficient of determination is 1, so it is an exact fit. Which should make sense since it was area, that it should be an x squared. That should be enough for you to finish your homework.